All right, I think we're going to get started. Hello, everybody. My name is Andrew Kalnan. I am the Associate Director of Alumni Relations here at Dickinson. I've been at Dickinson for about 2 years now, and I am the coordinator for Virtual Alumni Week and also Alumni Weekend when things are in a normal world. So I just want to say thank you for joining us today and for engaging with us this week. It's been a great week so far, and we have another great program lined up for you this afternoon. And today's program is a data science initiative update, which many of you have probably seen the description was supposed to come from Emily Marshall, but you'll see we have Dick Forrester here, who is not Emily, who is going to run today's program for us. So without further ado, I'm going to turn it over to Dick for today's program. Thanks, Dick.
All right, thank you. Hi, everyone. I am Dick Forrester. Emily Marshall sends her apologies for not being able to be here today, but I'm happy to step into that role. So I am a professor of mathematics and data analytics here at Dickinson, and I'm actually co-chairing the new Department of Data Analytics along with Emily Marshall. So really what we were kind of asked to do today is to talk about the data science initiative, how that evolved, and where we're at this point. So let's go ahead and jump in. You know, I figured a good starting point would just be to make sure that we all understood what is data analytics, right? I mean, if we're going to talk about data analytics and what's happening here at Dickinson, we want to make sure we're sort of on the same page. So there are a lot of different ways to kind of define it and describe it. What I like to say is it's the science of extracting information from data to uncover patterns, find relationships, draw conclusions, and make decisions. And so, you know, there's lots of different applications of data analytics. I mean, everything from predicting disease, tackling global warming, looking at income inequality, just it goes on and on and on. Let's talk a little bit about the timeline of the data of what's been going on with data analytics at Dickinson. So back in the summer of 2019, we actually had a summer study group. So we brought together a lot of different people from across the college, from the different divisions, and just really tried to bring together a number of faculty who are already doing data science type stuff, but we weren't necessarily collaborating. And we sort of brought everybody together to kind of talk about, you know, could we get some type of data analytics program going at Dickinson, and what might that look like? So following that, we were encouraged that the college was starting this new revolutionary challenge. And so, you know, the idea here was to solicit, you know, bold ideas that the college may consider investing in, you know, big initiatives. And so we put together a proposal around data analytics for this revolutionary challenge. We were selected as a Revolutionary Challenge finalist, sort of towards the end of the fall of 2019. And then once you've sort of been decided as a finalist, then the real work begins. And so we worked on putting together all of the documentation and everything else, and got that submitted in the spring of 2020. And actually, the final documentation was submitted in June of last year. Now, Math 180, as we're going to talk about soon, is actually a new Intro to Data Analytics course that was designed by Professor Jeff Forster, and that actually started for the first time in the fall of 2020. So that was sort of our first toe in the water of something that is specific to data analytics. But as I'll talk about, we're actually, you know, we're already teaching a lot of this material in other courses, but this first course, this Math 180, was really built around, you know, specifically looking at things from a data science perspective. Now, we found out that that we were one of the sort of winners of the data analytics, or of the Revolutionary Challenge, towards the end of fall 2020. And based on winning that, we put together an APS-C document. So the Academic Program and Standards Committee is sort of the main academic committee that evaluates new programs, evaluates new courses. And so we put together a proposal, for this new major and then submitted it at the beginning of the spring 2021. Right about the same time, we did receive enough funding to hire 2 visiting assistant professors. So we've actually hired 2 new visitors that are going to be coming to Dickinson. We're very, very excited about them, and they're going to try and basically round out the expertise that we already have here at the college. This, I guess I already talked about this. We went ahead, we did a visiting assistant professor search. Emily and I ran that. We were really happy with how robust the pool was. If you don't know, there are not enough data analytics folks out there, especially people that want to teach at universities and colleges. There's just not enough people out there. And so we were really anticipating this being a tough search, but we were really surprised to have a very robust pool. We had a lot of very good candidates, and the 2 people that we ended up hiring we're very, very excited about. Let's see here. The first data science major was actually declared a little bit before the end of this past semester, and we're expecting a lot more will be coming. And the new visiting assistant professors will start in the fall of 2021. So in other words, this coming semester. As we're going to see, there were actually 4 new courses that were designed specifically for this major. This Data 180 was that introduction to data science, which is now coming up on a couple of years old. And then in the spring of this coming academic year, we'll be offering Philosophy 258, which is the philosophy of data science, and then also the Data 200 course, which is a data systems class. So kind of learning about how do you remove data from data systems like databases and scraping stuff off the web and things along those lines. So that will actually be offered in the spring of 2022. Data 300, which is a machine learning class, will be offered for the first time in the fall of 2022. And then finally, Data 400, as we're going to see, is a capstone course. And this will be offered for the first time in the spring of 2023. And then we should be graduating our first data analytics majors at the end of that spring semester. So I should have mentioned this at the beginning, but if you do have questions, feel free to use the raise hand feature. I probably won't be watching the chat right now. It might be a little bit too distracting, but if you hit the raised hand, I'd be happy to answer any questions as we move along. So back during the summer study group, we really wanted to make sure that we involved as many people from across the college as we could, right? Data analytics really is very multidisciplinary, and we wanted to make sure that we were hearing from everybody. That includes, everybody from the 3 academic divisions of the college. We wanted to hear from admissions and athletics and institutional research, and wanted to really try and bring everybody together. And so the original data analytics team had 45 people from across the college. So, these individuals were, had varying amounts of contributions, but everybody was consulted. We wanted to hear what they had to say. So why would you want to do data analytics in the liberal arts? Data analytics or data science, they are very technical fields. I mean, you do need to have a considerable amount of technical expertise in order to do data analytics or data science. That's why a lot of the data analytics programs tend to be more at the university level. They tend to be at larger institutions where, they can really focus on that technical stuff. Well, so why should Dickinson have a data analytics program? Why would you want to do data analytics at a liberal arts school? Well, it turns out that Emily and I are actually finishing up an article for a magazine called Education Reimagined, where we actually go through sort of why doing data analytics at a liberal arts school is actually really, a great idea. But just, kind of a brief overview is that data analytics really does transcend traditional disciplinary boundaries, right? We don't just stay in one silo. It really is across the board. Liberal arts education really does prepare students to live, to meaningful comprehend and critique and construct data-driven arguments. Specifically, what are they going to learn here at Dickinson? Well, they're going to learn to be adaptable, engaged citizens and agents of change in, a world that is just completely overrun with data. So what are the different characteristics of a data scientist? So there are all these technical skills, right? In order to be a data scientist, you need to have a strong background in computer science. You need to have a strong background in statistics. You need to have a strong background in mathematics and a bunch of also, kind of related fields. And they all come together to really bring you this knowledge. Now, certainly a liberal arts school like Dickinson we can make sure that we cover those bases, the technical skills. But where we really think a liberal arts school like Dickinson can really shine is in the soft skills. If you're somebody that works in the data science field, you know that it's these soft skills that really end up separating you from everybody else. And really, liberal arts education really is such a great place to learn those soft skills, that really define what a great data scientist is. And so what are some of these things? I'm not going to spend too long on these because it will get a little bit tedious, but these are the ones that we were putting together for this article that we're finishing up. So the first one is the ability to define a problem statement and ask the right questions. And so when you apply data analytics, right, what you're really trying to do is you're trying to form and answer questions. And so while it's easy to come up with some questions, it's even more difficult to come up with the right questions. And so we really believe that, a liberal arts education steeped in philosophy and history and the sciences prepares students to ask the right questions. And again, if you can't do that, you're not going to be a great data scientist. Number two, the ability to adapt and evolve with an ever-changing set of technical skills. Now, I think this is a big one. Data science is changing almost every day. The technical details, the computer systems, the software, the techniques, every day there's something new that is happening, and it's very difficult to stay on top of that. If you go to more of a professional school, they're going to teach you these techniques, but it's going to be very difficult to go off and to learn on your own. And I think any data scientist is going to tell you one of the things that they do is they need to stay current with the field. And so liberal arts is very, very good at teaching people to be self-learners. How do you go off and learn on your own? That's what Dickinson does. Dickinson prepares you to be able to go off and to learn on your own. And this is going to be a very important skill for data scientists so that they can stay current with what is happening in the field. The development of interpersonal skills and the ability to work in teams is vital. Data science is not done, in a cubicle. It is done in teams. And so, Dickinson is great at preparing people to work in teams and those great interpersonal skills that are important. The ability to communicate effectively, right? I mean, data scientists need to be able to explain their results to, a technical audience, but then also to a layperson's audience. How do you explain what you did, what your recommendations are, why your strategy was valid? You've got to make sure that you can get those points across so that people can actually apply and believe what you're doing. And as we know, a Dickinson education is great at preparing you to be an effective communicator. Curiosity, right? So what do I mean by that? If you're going to be a good data scientist, you got to be curious. You've got to be thinking about, why is this happening? What is interesting about this? And that's going to really drive you in order to be a great data scientist. And intellectual curiosity, again, is something that is developed at liberal arts schools, and Dickinson in particular. We're going to see that the new data science, our new data analytics major at Dickinson requires you to take an ethics of data science course. And so this is very important. There are a lot of ethical issues that come up when you're practicing data science. You need to be worrying about things like discrimination, privacy, consent, trust, justice. And this just goes on and on. And so, in order to be able to tackle and understand those ethical foundations, you have to be prepared to do it. And as we know, liberal arts is very, very good at having you understand ethics and morality and empathy when you're applying these things. Holistic approach, meaning just bringing together all these different ways of looking at a problem. And again, that's what liberal arts is all about, right? Looking at things from different perspectives. There's not just one way to do it. Domain knowledge. Domain knowledge is understanding where the data you're looking at came from. If you're going to build some type of statistical model or analyze data, you got to have some understanding of where this data came from. And so again, a liberal arts education like Dickinson is great about giving you sort of a broad-based view of a number of different things, right? Everybody has to take science and all these classes from all the different divisions of the college to prepare them to have this ability to kind of jump into almost any domain. And then when you tie that in with being self-learners, you can pick up the rest of it, right? And then just to kind of round this out, problem-solving skills are something that Dickinson is great at bringing out there. And then finally, eager to engage the world, right? I mean, any field like data science, you've got all these technical background, but eventually you've got to go out and you've got to apply them, right? You've got to get out there and you've got to make use of them in the real world. And so, where Dickinson really shines there is our heavy use of things like internships and externships and research experiences and study abroad. And so, really these 10 things that I went over, I think is really where Dickinson is going to shine and will be able to prepare that next generation of data scientists, because we'll give them the technical background, but then all these other soft skills that are going to set them apart and allow them to really thrive, in their position, whatever they decide to go on to do. So continuing on with that, was there an interest in data analytics at Dickinson? Well, in the spring of 2020, there was a number of surveys that went out. I'm not going to go too much into the slide, but the surveys showed that there was a considerable amount of interest at Dickinson, both in a data analytics major, but then also just in the college offering more data analytics type classes, right? Even if you didn't want to be a data analytics major, maybe you just want to learn a little data analytics so that you could apply that to whatever field that you're in. And so, the survey results showed very positively people wanted this type of a program. In terms of the number of majors in quantitative fields has actually been increasing. So if you look at the line chart on the left, you can see the number of majors in computer science, economics and quantitative economics and mathematics that have from 2006 to 2020. So those are actually the numbers there. And so those are showing an upward trend, right? Dickinson students are becoming more and more interested in these quantitative fields already. And then on the right, you can see the percentage of Dickinson's graduates that are in one of these type fields. And so you can see that in 2020, it was just over 20% of Dickinson students were in one of these listed majors here. So what about from a prospective student, right? I mean, part of what we're trying to do with data analytics is fill a need, but let's face it, we'd also like to bring new students to Dickinson. And so, while it's great if we could, some of the students that are, say, current math majors want to move into data analytics, or somebody that's doing economics or computer science maybe wants to do a dual major. I mean, ultimately, what we'd like to do is to bring new students to Dickinson, right? Students that wouldn't have gone to Dickinson otherwise, but actually bring them in because of this new major. And while that's a very difficult thing to quantify and guesstimate and predict, we do feel pretty strongly that this is going to bring in new students that wouldn't have considered us otherwise, right? It is still a rarity for liberal arts schools to have data analytics. Now, I think that will change. I think over the next 10 years, you're going to find more and more schools will start to have these programs. I think it's great that Dickinson is at the front of this, right? There's very few, but we're now at the forefront of this. We're getting this thing off the ground, and I think that's going to make us a leader in this field. But I feel very strongly that not only is, just the interest that's already here, but I think this is going to bring in new students and ultimately strengthen the college as a whole. And it really does fit in with Dickinson's vision, right? To provide a useful, innovative, and interdisciplinary education in the liberal arts and sciences, to prepare students to lead rich and fulfilling lives and engage global citizenship working for the common good, right? So this is sort of the goal of a Dickinson education. And we really believe that data analytics will be able to accomplish this. So what can a student do if they major in data analytics? Well, first of all, we think our majors will be well positioned to go right into a job right out of Dickinson in the data analytics field. We think we'll have a number of students that will do that. We also think we'll have a number of students that may want to go on and further their education and maybe go into a master's program or something even higher than that in data analytics or related field. We know that employers want to hire college students that can write coherently, think creatively, and analyze quantitative data. But as with almost any degree you get at Dickinson, you're not locked into that, right? If you get a data analytics major, you don't have to do that as your career. I think this will open up a lot of avenues. Students will go off, and I'm going to be looking forward to hear what they do. But you're not being locked into that track. So we really think our students will have a lot of opportunity. As I mentioned earlier, but here is an actual statistic here. It's estimated that there is going to be a shortage of 190,000 people who actually can do data analytics. So there really is this need that Dickinson is trying to fill. And again, we're trying to do that from a liberal arts perspective. So let's see. So what can students do with the data analytics major? Well, really, they can go off and do anything from analyzing data to all the other wonderful things that our Dickinson students do. So what I was going to do now is just briefly talk about the specific curriculum that we develop. But maybe now is not a bad time just to see if anybody had any questions about the process. Of how we got here, but otherwise I'm going to move into the curriculum. So does anybody have any questions about the process or anything?
There was a question from John and Nancy Taylor, class 6, and they asked, will you describe what backgrounds you sought in visiting professors? Sure,
great question. So it shouldn't be too big of a surprise that there really are not a lot of PhD programs in data analytics in terms of the number that they're actually, sending out into the world. And so, we were not going to require necessarily that we would have somebody with a PhD in data analytics for a number of reasons, right? Data analytics is something that is used in a number of different fields. And so what we did is we did actually advertise in a number of places where mathematicians look, computer scientists, economists, and also in the data science realm. And so we really got people from all over the spectrum. We got computer scientists, mathematicians, and economists, and people in analytics as well. We got a good array of those. And so really what we were looking for is we were looking for somebody that had the technical skills, right? Data science is different than statistics, okay? There are a number of differences in the way they approach data. And so we wanted to make sure that whoever we hired, we were convinced they had the skills necessary. They understood those technical skills, both on the computer side, on the computer science side, but then also the more data science oriented techniques. We also wanted to make sure that we got somebody that understood what a liberal arts education is, right? I mean, if our program is going to succeed, we want to do it from a liberal arts perspective. And so it is really important that we brought in folks, excuse me, a lot of talking here. We wanted to make sure that we brought in folks that understood what a liberal arts education is and would be able to, help us take that vision forward. How do we approach data analytics from that liberal arts background? So what we ended up doing is the two people that we hired, we did hire one that is an economist, but his background is very data science oriented. If you look at the tools and the way that he handles things, it is definitely applying data analytics. And his background, though, is more in, from the economist side. The other individual that we hired, she comes from a business analytics school. So definitely more analytics. Again, somebody that is applying all of those tools from data science. So in summary, what we were looking for were people that had data science, a strong data science background. We were not necessarily saying they had to have a PhD in data science. In fact, we were almost concerned about that because we were a little concerned that they might be too much on the technical side, as opposed to, again, somebody that can help us move forward the liberal arts approach. And so we were very happy with the two individuals that we hired. We feel very strongly they have the technical background, the soft skills, and understand things from a liberal arts perspective. So that would maybe been a little bit more than what you were looking for, but that would be my my summary of that. Great. Any other questions?
One more question from them too, Dick. How were employers and grad schools brought in upfront and ongoing to guide curriculum, and were there advisory boards?
Sure, great. So yes, we engaged alumni in a number of different ways, okay, through contacts that faculty had, through contacts that alumni's relations had, to solicit information. And it was really widespread because of the revolutionary challenge. Because Dickinson alumni were very involved in the revolutionary challenge, we were hearing from people all over the place. We were contacted by countless people that do data analytics managers, people that are new to the field, people that are doing data analytics at other universities. And so we really heard from a lot of different people. When we were developing our curriculum that I'm going to talk about here, there were a number of things that we did. One of the starting points was actually this document called the Park City Data Analytics Curriculum. And this was a bunch of people that had come together, I think it was 2 or 3 years ago, and it really sort of said, these are the skills a data scientist needs. And so that was sort of a starting point for us because they had built out what a curriculum should look like. In addition to that, we did bring in somebody from Dickinson University. So Dickinson University is another great liberal arts school, and they really were one of the first liberal arts schools to have a data science curriculum and to get it off the ground. And so we brought in somebody from Dickinson to come in, and they spent a couple of days with us, and they talked about what they did to get their program running, what worked well, so that we could, because in a lot of ways, Dickinson is very similar to Dickinson. And so they were sort of one of the first, and we brought them in. And so we talked to them about their curriculum, what worked well, especially in a liberal arts environment. In addition to that, again, there's been a number of different advisory boards. So we've really been getting information from alumni, from experts, and then, as I said, this Park City document was very, very crucial to looking at, what all the experts said, really is needed. So I think we've definitely included a lot of people, and we're going to continue to do that in the future. I mean, I received 2 emails today from recent alumni. And Emily and I had a meeting 2 days ago with another one that are all doing data science right now that have reached out. They want, they're offering up, to chat with, current students alumni. And so we've got this great base of people that are willing to help and that we've consulted with. So great. Anything else? All right. Well, then let's move in and let's talk about the curriculum here. So really, it's broken up into 5 main areas. So really, there is the foundational courses in mathematics and computer science. So I mentioned earlier that data scientists need a strong background in math, computer science, and in statistics. And so a lot of those courses were already present at Dickinson. And so that sort of forms the foundation of the major, were these courses that were already here. Then we have the core courses in data analytics. So again, we're putting together 4 new courses that were not on the books at Dickinson that are going to sort of fill in the technical background that is necessary. Again, that's focusing more on the technical background, but certainly from a liberal arts perspective. We then have the foundational domain knowledge. So I already mentioned that domain knowledge is an understanding of the data that you're looking at, right? Again, you can't make a model if you don't understand where that data came from. And so as you're going to see, we're going to require all data analytics majors to get domain knowledge in some area. And then the idea then would be that in their senior project, in their capstone project, they would apply their data analytics techniques to that domain, right? So we're going to make sure that they have this domain knowledge in order to apply the techniques. The experiential learning component, right? I'll talk more about that, but students are going to be required to have done something like an internship or a research experience, on campus or off campus. And I'll have more to say about that. And then finally, the ethical considerations that I already mentioned. So these are really the 5 things that really make up the major. And so here is a diagram. It's a little bit, once you've looked at it, it's not too bad. But this is an overview of the major. And so you can see most students will start with Comp 130 and Data 180. And so Comp 130 is an introduction to computing, okay? So it's an introduction to, just to computer science. It does focus on the Python programming language, but the main purpose of the course is to just give students a background in computer science. Data 180 is that new intro to data science course. That's a couple years old at this point, and that's really focusing on sort of the data science viewpoint of how you tackle data. And again, this is pretty different than the other. We have a number of statistics courses on the books here at Dickinson, and the Data 180 course really looks at things from a different perspective, and it dives in deep using the R programming language and sort of talks about some of the tools and techniques of that. Once you've had data, and in addition to the Data 180, you'll see over here on the right, we sort of have this sequence, this purple sequence of classes that really represent the mathematical background. And these are courses that were already at Dickinson. So we basically require students to have single variable calculus, multivariable calculus, and then they have to take the Math 225 and 325 sequence. So basically what those are is they are a sequence that looks at statistics. So it focuses more on statistics, but it does it from kind of a viewpoint of where we want to balance a practical look at statistics, but also looking at it from a mathematical perspective. After the Data 180, we have the Data 200 course, which is a data systems and database management course. And so a lot of data resides in databases or on the web. And so our students need to understand data systems to be able to pull that information on and extract it, whether it's from a relational database or pulling it off the web. And so that course really focuses on that. But it also does introduce some additional data science techniques as well. Data 300 is our machine learning course. So this will be focusing on all of the main, machine learning algorithms, and again, trying to strike a balance where it's going to have a theoretical side, but then also a more practical side. And then sometime after Data 180, you'll see our students do need to take this philosophy of data course. So we're very excited about that. And that'll be offered for the first time in the spring. I think that's right, the spring of this coming academic year. And so again, that's going to be focusing on all those ethical considerations that we talked about. Students are required, again, to take this 3-course discipline sequence. So I'll show you what disciplines are included in that in a future slide here. It might even be the next slide. But essentially, students need to complete this sequence before they go into the Data 400. So basically, everything needs to be completed before the Data 400 course. It is our senior seminar in data science. And so what's going to happen in that course is students will be expected to take that domain knowledge that they've learned and couple that with all of the technical expertise, and then really tackle some type of interesting problem to them in that field. So that's sort of the idea there. We also have that experiential component, right? Students will be required to have completed an internship or an externship or a research experience, in order to kind of show that they've applied these things in the real world. I'm not sure how well you're up on the current Dickinson curriculum, but there is what is affectionately called the WID requirement. And so Dickinson's writing requirement is actually a writing in the discipline. And so the idea here is that each discipline approaches writing from a different perspective. And so we are going to approach the writing in the discipline by combining and creating a writing portfolio based on a number of different courses. So for example, at the end of the Data 200 course, students will have to create a document where they have, talked about some type of data pipeline that they've done and how they've applied it and these other things. Same thing with Data 300, Philosophy 258, and then in Data 400. So we basically are going to have them create a portfolio where their documents that they're created are, how data scientists approach things from their writing perspective, both from, a technical standpoint and for non-technical audiences as well. In terms of the discipline concentrations, we were absolutely thrilled at how excited the other departments were on Dickinson here. And so I'm trying to remember, what do we have here? We have 16, is this 19 different departments that have already agreed for these 3-course sequences. And I think this is outstanding. So what this means is all of these departments have created 3-course sequences that students can take. And so what that would mean is they would take these 3 courses, and then the idea would be that they would apply their techniques in the Data 400 course to a problem in that field. So everybody, right? All these different fields believe that they have data that our students would be able to analyze. And I just think that's absolutely wonderful, right? I mean, this was not some small group. We've got great representation from across the different disciplines here at Dickinson. I think it also is a testament to how much data is surfacing throughout Dickinson, right? Data is not just in what people think of these, traditional quantitative fields, right? It's all over the place. And so we're very excited that they want to participate in this. Dickinson had such great support for this major. In fact, I think it's, probably had one of the best supports that Dickinson's had in forever. I forgot to mention this, when the data analytics major was approved at Dickinson this past academic year, 88% of the faculty voted yes. Now that's a big deal, right? 88% of the faculty supported this. And we do believe there's a number of reasons for that. One of them that it is very multidisciplinary, but also because we engaged so many people along the way. We heard from everybody during the creation of this major how we could get that through. So again, we've got great support here. We're very excited to see what our students are going to choose and how they're going to apply these techniques. The experiential component, again, I've already talked a little bit about this. We're already lining up internships, right? We've heard from from a lot of alumni that are letting us know about their internship programs, and so we're really building a great database. There will be other opportunities like research, on campus. There's already a lot of data sets on campus that we expect students that will be able to analyze. So again, students will be required to do this. And we're excited again to see exactly what our students go on to do. It can be completed anytime after you take Data 180 and Comp 130. That is a little bit light on the technical expertise, but we wanted to make sure that it was flexible. We suspect most of our students will actually have more than that, probably through Data 200 and 300 before they do their internship. But we did want to allow a little bit more flexibility. Let's see. So again, these are some different ways that could happen. Independent research, there's a possibility that it could happen during study abroad as well. Now, here's another interesting point. Do students need to major in data analytics? This is something that we've really been stressing to Dickinson students. This is funny. I hear this from students all the time. A lot of times they think, well, if I'm not going to major in something, then I'm not going to take any classes in it. And, I tell students this all the time. I'm an applied mathematician by trade, and I try and encourage my students to take as many computer science classes as they can. And that's the same thing with the data analytics. We've really been trying to get the word out that we've got these great new data analytics classes, and we're not worried about them just being filled with students that want to be data analytics majors. We want these classes to be filled with students from across the college, right? We would love to have students who are in music or history or classics to come in to take these courses. They're not going to get a major, but they could take these courses, learn about some of the material, and then apply them to the things that they look at in this discipline. And so we're really trying to emphasize to students, hey, we didn't just build this out just for the data science majors. We want this to be something that is engaging to the whole college. And so, in fact, let me actually hop to here really quick. So the major is where we started. And so one question you might have is, why did Dickinson start with a major? Well, I think it's pretty easy. There was actually a lot of debate about what Dickinson should do during that summer study group 2 years ago. And pretty much everybody said Dickinson has got to shoot for the stars. And that's why we were so happy that this occurred during the Revolutionary Challenge, right? Because that really was the vehicle to make this happen. There have been some other schools that say started with a minor, and they've already run out of resources, right? It is difficult to get this going. So Dickinson actually went the other way. We wanted to start with sort of the crown jewel, get the major up and running, get the program going, and then we're going to build out sort of some of the other initiatives that we want to do. For example, there is a good possibility that we will offer a minor in data analytics or possibly even a certificate. Now, there are some issues associated with trying to figure out how to make those work, but those are things that we're going to look at. We wanted to start with the major. Once we, really have that foundation down, then I think it's easier to build out these smaller programs, okay? So that is sort of our hope, would be to get like a minor and or a certificate if we can figure out ways to get over some of these hurdles. We also want to make sure that, we have all these partners throughout the college. And I already mentioned this, we had so many people that are doing data at Dickinson, their students don't want to have to get a full major in data science. And so our goal is to make sure that we start to offer more data analytics classes that are designed for non-majors. I mean, the courses we've developed certainly can be handled by non-majors, but they do have a little bit more technical background that'll be required. And so I think our hope is to sort of build out, you know, more classes that could be taken by anybody, right? Like take a text analytic class, right? That has very little background. And that would be something, say, somebody in the humanities, the classics department, they would be able to take without having a strong background in math and computer science, and then they would be able to apply it. And so that's something that we're hoping to add as well. Again, having classes that'll be more accessible to people outside of the discipline. We're also hopeful that we'll have some data analytics spaces that will be developed, right? Computer labs, office spaces, and you know, things of that nature where that'll be just designated for data analytics. Whether that's a place where students, you know, building off of the quantitative reasoning center, where students can come and have data analyzed and meet. And so we're really hopeful with that. And so that's really what the revolutionary challenge is about, is really helping us to build out these, you know, these future directions. And so at this point, I'm happy to entertain other questions about the curriculum or data analytics at Dickinson in general. I can't see. If you guys do not have any questions, I'm happy to talk a little bit about, you know, my research here, but otherwise, I'd love to hear your thoughts on this.
I didn't see any other questions in the chat, so if anybody wants to unmute themselves, feel free to do that as well.
Yeah, Dick, John Taylor here. There's a lot to like in this, and I actually think this will set Dickinson apart for years to come. I'm not sure that data science in 2021 will look like data science in 2023 or 2025, but it's an evolving thing. One of the, I love the idea of building in the respective other disciplines, because having been in the venture capital business, I know that, you know, that's what drives things, real world, practical applications. Can you give me an example of some of the thinking of, for example, incorporating music majors or, you know, music and some of these other non-STEM disciplines? What might an example be of how someone might approach that?
Sure. So again, I am not an expert in those fields either, so that makes it a little bit challenging for me. But let's talk about you know, classics major, right? We've already had some data analytics projects involving classical texts, looking for patterns, right? So, you know, how do you use pattern recognition and text analysis tools in order to look for patterns and trends, right? You can do the same thing in history, right? Or philosophy, trying to look for where these trends are. In music, you know, there is a lot of mathematical structure, right? So how do you, you know, analyze math or you know, musical structure, maybe to do something like, you know, just an example there, what makes a good pop song, right? Analyzing all of the pop songs that have happened and trying to figure out, could you predict what's going to make a song a hit? And I know they already do that now, right? I mean, when they're getting ready to release new songs and stuff, they will actually send these through machine learning algorithms and say, do you predict that this will be a hit? And they'll try and focus on that, or maybe make modifications based on that, right? So I think, you know, they can do similar things like that in music. But again, I think every one of those, you know, 19 majors that I threw up, they have data that they feel needs to be, you know, analyzed. And I think, you know, it used to be people were like, you know, well, in my field, we don't look at things quantitatively. And I think everybody's realizing that there is almost no field now that where, you know, a quantitative viewpoint isn't going to be important. And in a lot of fields, you just can't go any further without being able to analyze things quantitatively. And so again, that's why we're also hoping to get even more courses for non-majors on the books, because maybe there is a music major who wants to analyze things, or a classics major, and they just don't have the background, and they can't squeeze enough of the classes in. And so trying to even get some more of these classes in there so that we can help prepare those students. You know, they don't need to be full-blown majors, but to be able to analyze the data. And so I think that, you know, again, all of these fields have that data. I wish I had some better, you know, examples, but, you know, I know that stuff is out there. So I do see a question from Natalie. Hey, Natalie, an old student of mine here. She's wondering why we didn't include linear algebra. That is a great question, a little bit more technical. So we did actually have linear algebra in an earlier version of the course, but there's a couple of things I would say. The main reason is it was really hard to figure out how to squeeze that in, right? If you're going to be a liberal arts school like Dickinson, we sacrifice a little bit of depth in order to get that breadth. That's what a liberal arts school is about. And so there was not really a way to squeeze in a linear algebra course. We had talked about actually creating a new linear algebra course that was more applied. You may remember, Natalie, that our linear algebra course requires our discrete math class. And so that would set up that prerequisite chain. And that's why we had talked about maybe adding a new applied linear algebra course. Linear algebra is definitely important, especially in machine learning. But what we feel we can do is we can work around that and introduce the linear algebra that we need to still allow our students to you know, understand the mathematical foundations of some of these algorithms. So the very short answer is it was too hard to squeeze that in from a technical standpoint, right? I mean, at a liberal arts school, we're looking at that broad-based view of things. And so it was a little bit harder to squeeze that in. And I think at the undergraduate level, we can accomplish that. The last thing I'll say about it is we do have recommendations for our majors if they're thinking about going on to graduate school. And we do have down that if you are thinking about graduate school in data analytics, we are recommending that you take linear algebra. So that's the short version of it. It is an important, I mean, I think linear algebra is the most important math class there is. I love linear algebra. I just taught it this past semester. It's one of the most important classes out there. But again, you got to sacrifice something. And for the types of majors we're bringing out, we think we can do that.
Thanks.
Yeah. Hey, Natalie.
Hey.
That answer your question?
Yes.
Great. Let's see here. So Tom Lusby had asked if I can demonstrate a research example that I've done in this field. So I am actually an applied mathematician by trade. And so I actually do operations research. So this is where you use you know, mathematical models to solve complicated decision problems. And so my research is really not so much in the data analytics field as it more is in the decision science type field. So, you know, a number of my research projects have been more about complicated decisions than applying, say, than straight up analyzing data. You know, just some student projects that I've done here at Dickinson. You know, I worked with a student to develop a crop rotation model for the Dickinson College farm. So crop rotation is the primary way that you keep your fields healthy without using, you know, synthetic fertilizers and pesticides and stuff. And so we had developed a mathematical model in order to figure out how do you optimally rotate the crops in order to meet these different restrictions. You know, first year students have to take a first year a seminar, and what they do is they pick 6 different seminars that they're interested in and rank them. And so a student and I had actually written a couple of papers about what is the best way for, to assign students to seminars. I actually did the first year seminar assignments on last Friday. So I somehow I did this as a student project, and now I've been stuck for the past 10 years assigning students to seminars. So I actually did that last Friday. Another example, and again, a lot of these things are tangentially involved with data, right? There's a lot of data involved in the projects that I'm doing, but I'm more on the decision side of things. So one last one has to do with, I did a student project on looking at how do you tour a theme park. So if you've ever been to, Disney World, the Universal Studios, I actually have my youngest sons at Hershey Park today. What order do you visit the rides in? Because the wait times actually vary considerably throughout the day, and they follow all different sorts of patterns. And so I have a paper with some students and some colleagues at Furman University where we developed some different algorithms based a lot on data, right? We had a lot of data on wait times for rides. How do you, decide what order do you tackle these rides in order to minimize your wait time? And so a lot of my research, again, is more on the decision side, but I do use data in that. So hopefully that sort of answered your question. But I do have a pretty strong background in computer science and statistics, and so I've really been enjoying kind of moving more towards that data analytics side. Let's see, Dale Ziegler has a question. As a member of the Alumni Council, we've talked about certificate programs for alumni. You mentioned this would be potential for a great benefit of those wanting advanced knowledge and information in data analytics. Would highly recommend a certificate program for both students and alumni. Yes, I agree. I think a certificate program could be a great way to go. Whether we decide to do that or a minor, there are some technical differences here at the college and in terms of making that out. But I definitely take your point. For current students, I definitely think we are going to develop some kind of a program that is less than a major, okay? That will make sure that students will have something that they can tout and that it's been organized in such a way that it's coherent, right? If you just take a couple of classes, they might not synergize. I think our goal is to figure out whether that's a minor or certificate or both. How can we come together with some classes to make sure our students have sort of a good foundation, nothing like a major, but that they can go on. And so that is definitely on our to-do list, and we're hoping to get there sooner than later. In terms of offering something for alumni, that is something that we've talked about. Dickinson has, dipped their toe in the water of graduate level classes. And so all I can say in that is, I definitely think that's something that the college could consider. I think there would be a great interest if Dickinson did something like that for alumni, offer some kind of a certificate. So that is definitely on our radar. And I appreciate you bringing that up. So any other questions? All right. Well, I hope everybody enjoyed the presentation. Feel free to email me if, myself or Emily Marshall. If you haven't already, if you just search for data analytics at Dickinson, you can go to our new webpage. If you want to read a little bit more about, the specifics of the curriculum, please email Emily or I if you have any questions. Again, we're hearing from people all the time. If you work for a place that offers internships and you want to let us know about that, please do. We are keeping track of those. That is really appreciated. Any support from the alumni, whether that be financial through the Revolutionary Challenge, but then also, just if you've got some advice that you want to give, if you want to offer to talk to our students, or if you have some type of internship program, please let us know. All of that is greatly appreciated. We need your support in order to make this happen, right? We've got the two visiting assistant professors. That support has been brought in because of folks like you. And you know, in order for us to keep moving forward, we need your expertise and your time and your passion. So we really do appreciate that. So that's it for me then. So anything else?